All right. Hope you all have had a great month. So I've shared our agenda in the chat here. The first thing on to preface about what we'll be discussing today, I sent in the invite that we'll be discussing the upmap remap PG remapper, adding that to the balancer. I did ask Dan Vanderster to be on the call for that, and he's able to join later in the meeting. So we're going to discuss that part last. But if you came for that discussion, we will absolutely be discussing that. We've got two other topics on the agenda that people reached out to me to add on as well. So we'll cover those two first, it looks like. So the first one on the agenda is disabling stretch mode. And I know that's Junior's topic, so go ahead and take that away.
Cool. Okay, so I'm just going to share my screen. Are you guys able to? Are you guys able to see the disable stretch mode slide?
Yep, looks good.
Okay. Okay. So hi everyone. My name is Junior. I'm in the core team for Ceph, and I've been one of the maintainers for stretch mode and stretch clusters. So I'm just gonna go over quickly definition of stretch cluster. Basically, is a cluster that spans across geographically separated locations. It runs over like a wide area network, but it still maintains some sort of low latency connection. So probably works in like a metropolitan area when you have like two different data centers, and you want to be able to withstand 1/3 or half of the total loss of the cluster. So basically, if you have two data centers, you're able to withstand one failure of data center and expect the cluster to operate normally. It can also withstand net split scenarios. And it also requires synchronous replication because there are some latency. Therefore, all kind of like write operations they need committed to all its replicas before you're telling the client that the write has been complete. So what is stretch mode? Stretch mode is a subset of in the stretch cluster. It works with only 2 sites for now. With 3 sites, we had some problems with like monitor quorum, figuring out what kind of like monitors, tiebreakers, and things like that. So for now, it only works for 2. We have a plan expanding it to more. So basically, you would have 2 copies of data in each data center. You have 5 monitors in totals, 2 monitors in each data center, and you have this tiebreaker monitor, which is responsible for tiebreak when there is election between the monitor, choosing the winner of the election. And so with 4 replicas, the size is 4, and the min size for all the pools are 2. The connectivity mode in the monitor election algorithm is basically when each monitor has a copy of their peer monitors connectivity score. So monitors will ping each other consistently, and based on how good the connectivity are, they come up with a score. And during election, whoever has the best score wins the election. Another characteristics with stretch mode is that we extend the peering rule such that in the acting set, the OSDs must be for multiple data centers in order to serve I/O. So what this does is that it prevents certain scenarios where you would that could be you're writing to data center 1 and suddenly the OSDs in data center 1 that is responsible for that PG is down, but then you're allowing yourself to write purely to data center 2, where the versions of that PG kept incrementing, and then there's a scenario where simultaneously, okay, data center 1 comes, the OSD in the data center 1 comes back up, but then you didn't get enough time to get the latest version from DC2, but then you lost one data center, so you're now facing with a data loss because you won't get the latest version. So with that new peering rule, you basically prevent that scenario from happening. And also the OSDs connects to only monitors within its own data center, which they are located. This is because you don't want OSDs connecting to the tiebreaker monitor if there's a net split, because then how do you know which data center you choose to be to be in survival or to form quorum and to operate in that only surviving data center. So how do you enable stretch mode? You have this command, ceph mon enable stretch mode. You input the tiebreaker monitor, the stretch rule that you define, and the bucket type, which in our example is data centers. So you have to ensure that you're adding host and data center into the crush map, so that crush is aware of this topology. Then you create a crush rule, which consists of 4 replicas, and step choose first n 0 type data center means that you're choosing all kind of data center. In this case, we have 2 data centers, so we're choosing all 2. Step choose leave first n2 type host, meaning you're choosing this first 2 hosts in that data center. So in total, you would have 4 copies. So before entering stretch mode, all pools have to start out with the default size and min size. I'll talk about this later in the next slide on why we chose to do that. And it's to do with making disabling it easier. And after entering stretch mode, all pools will be using the stretch rule, and all pools will have a replication size of 4 and min size of 2. So yeah, in terms of why we have to ask the question why one would want to disable the stretch mode. And I think a month or 2 back, in this meeting, we have a user, Stefan Human, who brought up a pretty good scenarios where users might benefit to this. Is that when you're in a stretch cluster, stretch mode, and you lost one data center, you're in degraded mode, and you choose to not fix or not try to bring that data center back up, and you're okay with operating with just one data center, but you don't want that data center to be degraded, and you don't want, when you're in the degraded stretch mode, you only have min size of 1 because there was a business requirement back then where you want stretch mode to work to be higher availability. So one user might want to move back to the traditional setup. The other case is that the user might want to expand stretch mode from 2 data center setup to a 3 data center setup. And there is a feature that you can do that as well. It's just got recently available in Squid and the latest main. Basically, you can do stretch set pool, and what this does is that it generalizes the new peering rule that stretch mode has, and you can use it to work with 3 data center setup of a stretch cluster. So yeah, basically these 2 motivations are what made us provide a solution of disabling stretch mode. So let's talk about the command of disabling stretch mode. So ceph mon disable stretch mode, you can supply the crush rule. That's optional. And you have to put a yes, I really mean it flag, because this operation is quite big. You're moving from one mode where you're able to withstand net split, you withstand a failure from one data center to a traditional Ceph cluster. So some of the requirements before you can move back is that you must be in a healthy stretch mode or degraded stretch mode, and you cannot be in recovery stretch mode. Recovery stretch mode means that when you lose one data center and the data center comes back up, there's peering that happens, and stretch mode just has a flag that we're recovering, um, we're basically trying to peer the PGs that are coming back up to the latest version. Well, obviously, you don't want to move back during this process, because moving back from the new peering rule to the old peering rule while PGs are peering, it's a recipe for failure. So we don't want to do that. And so all pools, when you disable stretch mode, all pools will revert its size, min size to the default values. So that's one of the reasons why before you're enabling stretch mode, it has to be in default values like size and min size. If crush rule is applied, then it will revert to that specified rule that you specified. Otherwise, it will just use the default rule. Um, and these default values and rules could be configurable globally using Ceph commands. It's in the documentation if anyone's interested. Peering rule will be revert back to normal. So acting set no longer requires OSD from both data center, because this concept of both data center doesn't really exist anymore. And the monitor that is marked as a tiebreaker, who's responsible for deciding the winner of the election, and a tiebreaker monitor also cannot elect itself as leader. So that monitor who lives outside from those two data centers will no longer be tiebreaker, and it will become a normal monitor who can be a leader. And the election strategy remains the same. Connectivity, just because I think connectivity is really good. Before we used to have a classic mode where we only care about the ranks of the monitor. So if you have whoever has the least rank gets to be the leader. So we kind of keep that as default. Yeah, if you can check out my PR that has been filed, it's basically pretty much like passing tests and ready to be merged whenever it gets approved. And yeah, would love to hear your feedback, and thank you.
Thanks, Junior. What questions do people have about this new option for stretch mode? All right, if nothing, thanks, Junior, for sharing that. And is this in the documentation yet?
Yeah, so in the PR, I did open a documentation explaining the commands and what are the requirements and things like that. Yeah, I did include it in the PR. Yep.
Cool.
Okay, I have never played with the stretch mode, so I have some maybe stupid operational questions. So, is it possible to have erasure coded pools in stretch clusters?
Yes, great question. Right now, no, we don't support erasure coded pools yet. I think it's one of the big projects we're trying to move towards. But that would be a really big milestone for erasure coding. Yeah, thank you for asking that. Yeah.
Okay, so only replicated pools so far.
I see a question from Joel. Is connectivity mode better than classic mode for non-stretch one data center cluster? Yeah, great question. I think since you're taking out latency from, yeah, you're assuming in a one data center cluster, you don't have really much latency. So I would say, yeah, you're pretty much safe with just using classic. So yeah, I might just be overexcited with the connectivity mode. I think connectivity mode works well when you have latency between the monitors, right? So to answer your question, I think, yeah, classic works just fine.
One
Cool.
question here, if I can. So thank you very much for this. This is very interesting. I actually found the original tracker that you opened for feature request. I'm the other guy together with Stefan that has asked for that. I was just checking your pull request on GitHub. Is it actually sufficient to just change a few things on the Mon side? Because I remember Greg presenting all of his work in implementing stretch mode. And if I remember correctly, he also had to change quite a few things in the OSD map. It could be that I'm wrong. So I was wondering, is this really an operation that requires monitors to be aligned in stretch or non-stretch?
Yes. So, I mean, if you look at my code, there are some values that are changed in both monitor map and OSD map. So some of the flags that are encoded in the OSD map also gets changed when you disable it. One of the big things is a function called choose the acting set. We have this like special function that would only get triggered if you are in stretch mode. Basically, it uses that new peering rule that prevents acting set from choosing OSDs purely just from one data center. It needs to have both data centers. So that's one of the things, and it won't go into that particular set of code if the stretch mode flag is not there. So in a way, you might see that I'm not changing too many things, but it's because it relies on the flag that goes into that code path.
Okay, I understand. Okay, cool. So I see that there are backports planned for Reef also, which is pretty interesting. Is there any release planned anytime soon? I know that 18.2.4 is relatively recent. I was wondering if there are plans for this to be in a GA release anytime soon.
Right.
I
not
can
sure
answer that.
Yeah, go ahead. I think you know about that than me.
Yeah, so the 19.2.0 release will be done soon, and then after that we'll focus on, I believe, Reef and then Quincy. So for a while the focus was on 19.2.0, but then we'll be moving on to those two focuses.
Okay, so cool. So this goes all the way back to Quincy also. Okay, cool. Thanks, Laura.
I'm not sure if this plans to be backported to Quincy. I just meant that we'll be doing another Quincy release. Junior, can you answer that?
Yeah. So stretch mode. Yep. So just to clarify, stretch mode was readily available in Pacific, which is already not unsupported, if I'm correct. So I think it's safe to say that we could definitely backport it to Quincy.
Okay, thanks a lot.
Cool. Maybe Junior, if you have backports prepared, we can prioritize those for testing.
Yep. I guess I could just file backports concurrent with waiting for approvals. Unless there are some really major code requests changed. So yeah, definitely could do that.
Cool. Are there any more questions around this topic? Good questions, by the way. All right. If not, we'll move on. And thanks, Junior, for presenting that. Maybe if you could share your slides with me, we'll have this recording up, but I'll also link the slides if you are able to share them, Junior, to the.
Sure. We'll do that. Yep.
Thanks. All right. So the next topic here, let me check the agenda. The next topic, I'm not sure who added this one, but it's carbon system design in the Ceph dashboard.
Oh, hi there. Hi, I'm Ivo Mida. I am one of the developers in the Ceph dashboard team. So we added this topic this week, and I hope it's okay to talk about it. I know it was quite late. We added quite late, but
Yeah, that's okay. Go for
yeah,
it.
okay. Right. Let me just share my screen. Just bear with me a second. Right. Can everybody see my screen?
Yes.
Yeah. Okay. Cool. All right. So basically, like what I want to talk about today is the carbon design system. So we started introducing carbon design into Ceph dashboard for the 8.0 release. And I'd like to talk about what it is and what are motivations to introduce it, and and then I'm gonna be open for any questions that anyone might have. Okay. So basically, in Ceph dashboard, we had a few issues. So we don't have a dedicated UX designer to the team. So whenever we had to implement any new features, it was just up for the us engineers to come up with solutions, and sometimes there will be a lot of friction in our meetings and discussions. There are a lot of biased opinions, and none of those opinions were ever based on actual UX research and what would be most beneficial to the user. As a result of that, over the years, what people can see in the Ceph dashboard is that there is no consistency across workflows in the application. Like you can have different ways to achieve similar things in the application in different parts of the application, and that's a reason of this confusion. Like we never had like clear guidelines to follow, like a one source of truth in order to come up with those solutions. And on top of that, our application was a mix of third-party libraries. Some of those are deprecated now. Most specifically, the data table, which is the component that we use the most throughout the application. I think maybe 80% of the application makes use of this component. And because of all those reasons, we decided to look for some solutions. And that's where we came across the carbon design systems. So the carbon design system is basically, it's a design system, it's an open source design system that provides clear guidelines and patterns for creating UI screens, and also provides a set of components in Angular, which is something that we also struggle with as well. We previously looked into Patternfly, but unfortunately, Patternfly doesn't give us any Angular components. If we were to follow Patternfly or any other um, design system, like we will have to be creating the components ourselves, as we have been doing up to this point. And doing that, so introducing carbon improves the UX because of all the guidelines and patterns are based on actual research. Improves the developer experience as well, because now we have one source of truth that tells us how to do things, how to achieve what we need. And also, as a result, we also modernize the application, because we never had clear design guidelines or even a UX designer in the team. Like the application is a bit disjointed at places. And following a design system will allow us to achieve all of these, like modernize the UI, improve our developer experience, improve the user experience for the users, and more. And basically, those are what I was talking about, which are the benefits and strengths of the design system. And top of that, like of all the benefits that I have just talked about, it is also it has a really active community of support. Like if you, I'm going to include some links in the end to the GitHub repositories that are part of the design system and the Angular components. There's discussions going on there. Anyone can participate, send PRs, raise issues, and so on. And it is an open source project as well, both the design system and the Angular component libraries as well. Okay. The design and functionality consistency. Basically, as I said, like this will allow the application to have to be consistent. It will help us maintain an up-to-date application as well. We are going to have this one set of patterns, and there's quite a rich set of documentation as well in the Carbon Design System website, where you can see clear examples of workflows for adding, updating, deleting, and also like it also has guidelines on how to name things. I think one of the first trackers that I've seen, there was a long discussion between a member of our team and someone from the community of whether a button should be named update or edit. And in the end, none of them won the discussion. And as a result in the application, you can see some forms where you would have updates, others have edit. And in our integration tests, like we have to add like if-else clauses to catch those two forms of edit. This is just an example of the inconsistencies that we are trying to improve with the introduction of the guidelines of the carbon design guidelines, really. And also, as I mentioned before, one of the biggest benefits of Carbon is the component library that is provided. It is a community effort. It doesn't come from the actual core Carbon design team, but it is still actively maintained. There are active discussions about it. There are regular updates, and that's what we've been using in this once we started to introduce Carbon, and we had a very positive experience so far. And for 8.0, like I have a screenshot of what we have achieved so far. So basically, we changed the navigation, which you can see is the header and the left side navigation. So now this is a Carbon component. Obviously, it looks different from the previous one, but we're still trying to preserve the same some of the same colors of the original upstream project. The other one is the data table that I mentioned before. Like actually, you can see on this first screen here. It has all the same functionalities of the old data table. Plus, we moved a few. We changed some of the functionalities where before you have to select a row and then drag the mouse across the screen to the top and then select an action to perform on that row. Now you have like a kebab menu that you can activate on the row. As you click on the row that you want to perform an action, you just click on the kebab menu and then you do perform the action. And another feature of the Carbon data table is the batch actions, which is something that was not a feature that didn't exist in the previous data table. Now you can perform batch actions basically on whatever you can see on the screen, on the items that you can see on the data table. obviously there's pagination, so you can increase the number of items here in order to be able to select even more and perform whatever actions it is important to you. Not all screens are really prepared for that. We are going to add some features in different parts for different features to make use of this new functionality. Okay, and the forms. So this is the forms. This is an ongoing effort. Like we have some forms that have been ported to Carbon already, like this one to create a volume. But so far for 8.0, those are the main things that we are delivering. And outside the release cycle, we are going to continue working on implementing new features like to port current screens to Carbon. So this is something that's gonna happen like from now on every time on a continuous basis. And here are some resources to learn more about Carbon. I'm gonna share this presentation.
Thank you.
And
sorry, I
that's
didn't mean to
it.
cut you off.
No, I'm done anyway. Thanks.
Yeah, there was like the sound cut off, so I thought you were done. So yeah, thank you so much for that presentation. Does
Thank you.
anybody have any questions for Ivo about this design concept?
And can I just add something that I have I mixed up the version that I mentioned 20, and this will end up in the tentacle version only, by the way.
Gotcha. Well, are there actually any Avid dashboard users on the call? Maybe this will be the hook to get people started with the dashboard in Tentacle.
Yeah, hopefully.
Thanks, Ivo. All right, so I think we'll go to the last topic now about upmap remapped. So let me share my screen on that. All right. So I wanted to talk about this design concept for a feature we want to add. I'm not sure which release this will be planned for, possibly Tentacle, but we do want to consider, doing this for one of the upcoming releases. But to give some context, there have been these two tools that are somewhat interchangeable in the community for a while called Upmap Remapped and PG Remapper. Is anybody on the call familiar with those two tools?
Yes.
Yes. All right, cool. So feel free to chime in on this as I go and talk more about it. And I see another comment in the chat from Alex. Yes, you're familiar with it. So I was talking with Dan Vanderster recently, who has done a lot of talks in the Ceph community, different Ceph days, about upmap remapped and how that works. But essentially, these are external tools that have been used as workaround cases where clusters are experiencing a large percentage of misplaced objects due to if somebody adds a host or an OSD or draining a host or similar use cases. And when OSDs or hosts or are added and this large number of misplaced objects comes up, the balancer module is unequipped to handle this getting out of this case. So users in the community have been using these external scripts to run against their cluster to fix it. And here I've written down, Dan and I talked about like a possible scenario that somebody could run into. So here's a use case where somebody might use the upmap remapped or the PG remapper tool. So if the user is adding an OSD or a host to their cluster, or if they drain a host, then the cluster might experience a high percentage of misplaced objects. The PGs are remapped and backfilling or remapped and backfill wait. Those are the states that they're in. And then if the number of, or if the percent of misplaced objects exceeds the target max misplaced ratio in the balancer module, the balancer module does nothing except issue a warning that says too many objects are misplaced, try again later, something like that. Next, the PGs are in a remapped state, and this is where their acting and their upsets are not equal to one another, and backfill is still ongoing in this state. The progress bar in the Ceph status command shows the cluster will take many hours or days to get out of this state. Backfilling, get out of this backfilling state to an act where all the PGs are active and clean again. And this is the state that leads to people using this upmap remapped tool. So you would run the script and it creates upmap entries that align the upset with the acting set on the remapped PGs. Now the cluster is back to health okay, and it's no longer necessary to move data. And the balancer now works as usual to balance the OSDs by utilization. So ideally, we would like it so users don't have to. Or some people may not know about the upmap remap or the PG remapper tools, and we want to make it as easy as possible to just have this logic worked in with the module that people are already using to auto balance their clusters. So I've worked with Dan to map out this design proposal of incorporating the logic in with the balancer manager module. And again, the motivation is since these tools are separate from Ceph, it requires extra complexity on the user's part. And it's also patching behavior in the balancer that should be addressed. So the design proposal is if the percentage of misplaced objects exceeds the target max misplaced ratio, the balancer should issue mappings on remapped PGs to align the upsets with the acting sets. The balancer should address remapped PGs to stop rebalancing, even if the outside balancer time window, which is set by the user, the beginning time or the end time, is set. The balancer module should be aware of the number of OSD maps recorded in the cluster. If the OSD maps exceeds about 10,000, then the balancer should stop adding up mappings to prevent the monitor database from growing too large. And the balancer module should not create an upmap if it will lead to the PG going back into the backfill wait state. So this is very much a high level proposal, but the idea would be to again address this behavior where PGs are going into backfill and when the upsets are mismatched from the acting sets, and we've got a bunch of misplaced objects due to that, and the balancer should handle that case, or the balancer module. And so we will have this planned for a future release once we know for sure, for instance, if it will go into Tentacle or into future release. This tracker will be updated, but for those who are interested in following this progress, you can become a watcher on this tracker, and then you'll get updates about it. But I wanted to use the user dev meeting as a forum to add anything to this design proposal from people that are directly using it. So are there any details that people would like to make sure that we're aware of before we start on adding this logic to the balancer module?
Yes. Okay.
Good.
Basically, the issue that I am facing quite often in smallish clusters, something like 7 or 6 nodes, is that the whole server goes down. Lots of misplaced objects. The balancer goes out of its way because too many misplaced objects. And so just because of the randomness inherent in the crash algorithm, the crash algorithm assigns PGs to OSDs randomly and unevenly, and sometimes there will be some OSD that will become something like 90% full, while the other is 70% full. So this is also a failure mode where the balancer could have acted better, but doesn't. I understand that this doesn't get covered by this proposal to integrate the functionality equivalent to the upmap remap command, but this is maybe something that this scenario is maybe something that should also be looked into.
Okay. I saw, Dan, you had a hand up.
Yeah, I have
you want to
another
respond to
tracker.
that?
I have a tracker for that one. So if I understood what you're saying that OSDs failed, so that means that they get marked out. When OSDs are marked out, the mon will clean any up maps that were related to PGs where that OSD was like the primary, let's say, or was in the mapping. So then you end up with, because so if a host goes down, of course, I suppose you're not talking about the degraded PGs, because that's not the interesting point. The interesting point is the misplaced objects, right? Or are
Correct.
you want?
Yeah, correct.
Yeah,
I'm talking about the targets where the PGs would be placed at the end.
Yeah. Okay. So I mean, basically, I have so I have a tracker. I'm just looking for it. Basically, the balancer doesn't do anything if PGs are degraded, and that's a problem. So if there's, yeah, here it is, 66755. So I think that's your issue, and it's like, I think it's exactly like you described. You can have PGs stuck in backfill too full and degraded because the balancer will not upmap those PGs away from too full OSDs. So does that 66755?
Yeah, it's quite similar to what I described.
Yeah.
I already had that linked as a related tracker, it looks like.
Oh yeah, exactly. Yeah, exactly. Yeah, I think it would be very simple to fix that as well. There's just a condition in the code that checks if the PG is degraded, and I think we should just remove that condition, but test it.
Yeah, I think, and I've done work on the balancer module, but I didn't create the original, up map mode. I wasn't there to develop that, but I'm guessing that the logic behind not doing anything when PGs are degraded was just to not be doing anything if the cluster is in a bad state. Because I think the thought was, let's try to balance the cluster if it's in an active, clean state, and if it's not, let that resolve first, and then we'll try balancing. But then if we're in a situation where it can only be solved by balancing, then that doesn't check out for sure. Cool. So yeah, if you would like to, Alexander, if you'd like to add your situation to this issue, feel free to do so. Or if you want to, just take a look at the tracker that Dan linked and give a +1 that's the kind of case that you would want to be addressed as well, we can look into that. And yeah, Alex, I saw you were also going to speak. Go ahead.
Okay. Yeah. So one of the biggest hicks that I have today with our tool, and the problem also exists with CERN's tool, is that with the current model, there is a lot of unnecessary peering. So it works like you had your OSD, there's a bunch of OSDs, there's a bunch of peering. Then you undo this peering back to the original, which is extra peering. And I wonder, because this is built in Ceph, if this problem could be solved there. So you would add the OSD and the upmap item kind of at the same time, and slowly undo the upmap item that you've added, so that you avoid twice peering. Because what we found is, especially on NVMe cluster, peering can be quite expensive.
Mm-hmm. So can you explain again what leads to the peering?
So the process today is like as described in the proposal, if I understand it correctly, is a user would add their OSDs, right? And everything would be normal, except if misplace goes above a certain threshold, in which case you would cancel a bunch of backfills back to active plus clean, if I understand it correctly. And so you would have the peering of the new mappings, and then you have the peering of reverting that back. So my idea is instead just add the OSD, compute the mapping, add a map all in one OSD map update, so that you don't have this double peering.
I see.
Can I ask?
Go ahead, Dan.
Yeah, yeah, this is kind of fresh in my mind because I was using. Yesterday, I was working on a cluster with 2,500 OSDs, and all of the crush weights were wrong. They were all like scaled down by a factor of 20, something like that. And they were all, so I wrote a tool to fix all of the crush weights to make them correct. And then it's similar, and then use upmap remapped at the end to like kind of also put the upmaps back so that there's not so much misplaced objects. So, I mean, this idea of too much peering, I understand it very much, because if you have a large cluster and you want to do a massive change, like for example what I said, change all the crush weight, you effectively have to repeer all the PGs like maybe 100 times, and every time you repeer all the PGs, it takes on a large real active cluster that can take maybe even 60 seconds or something to peer a few thousand PGs. So it's very disruptive. Now, yesterday I was thinking about this, and I thought, would it be maybe one solution would be that we like open a transaction. I mean, from I know inside Ceph, of course, we can do this, but from outside, like some kind of utility, like you open a transaction on the OSD map, and then you make many changes, and then you close that transaction, and it applies. It makes one new OSD map instead of going through several iterations.
I mean, when I said we can solve it, yes, that was a bit of a misnomer, right? We can extract the crush map, we can get the OSD map, extract everything, and manually get with the OSD map to a bunch of stuff. But automating that with this tooling is almost impossible, right? Like modifying the crush map with automation is
exactly
because it's not a computer format, so that becomes
right. Exactly that. Yeah, exactly. That's why I would still for the intermediate thing, I would just have a Ceph command line option that says like open a transaction OSD map, then let you create all of the changes with the commands OSD prep reweight, and then apply.
Yeah. Yes, I was thinking about that. I was thinking about saying the balancer in like change command you would type or OSD PG map you type would just be staged in one atomic operation. Yeah.
But it still has the problem. So then you still have the peering latency and everything, all of this peering, but you only do it once.
Exactly.
Right? Yeah. I mean,
See.
so I think that would be a useful feature, but otherwise, I don't know your the other idea that you had about create an OSD and create the up maps all at the same time. I don't really understand that. How would that work?
Well, how that work the internals, I don't know, but the idea is to say like any peering is a latency event. Whether it's significant or not, it depends on the cases. And we don't really do augments anymore. We do new clusters, so I don't have some fresh data. But when we were doing a bunch of augments in our clusters, especially block storage backed by NVMEs, latency is measured in like below millisecond at this stage, maybe 1 or 2 milliseconds for some writes. If we recreate, for instance, a full host of OSDs, we will see or if we just create new OSDs, we will see P99 and P100 jump a bit. It's not like the end of the world and super significant, but it is there. And so I'm at this stage where I just want to get rid of everything, but that's maybe too specialized.
So I think maybe one way to incorporate this into this feature is that, normally the MGR balancer only creates something like 10 up maps every 60 seconds.
Yeah.
So this means it creates a peering event every 60 seconds, and it's a kind of small peering event, but it's like it's 10 OSDs, whatever. It's up to 10 OSDs. And up to 10 PGs. Now, maybe when the balancer is having this feature, I don't know, maybe it should do more. Maybe it shouldn't have such a limit. Maybe it should try.
I think there is a configurable to change that, isn't there?
There's a configurable, yeah. I mean, getting through this cluster yesterday with 2,500 OSDs, in the end, we removed all kind of like waiting and sleeping and waiting for peering to happen, and we just, as quickly as possible, created all something like 8,000 up maps, and that that closed the task within 5 minutes instead of taking 3 days, right? So I think there's some cases where we're doing it slowly doesn't help. Maybe that's how we can address your comment, Alex.
Yeah, I would look into changing the configurable for that, which should be in the balancer module documentation. It's like max up maps or something. But if it's set to 10, there should be a way to change that. Let me see if I can find it really quickly.
To be fair, my concern is not like the balancer itself, right? It's just if you had a host full of OSDs, so let's say 24 of them, you're going to have thousands of PGs at peer in succession, going to go into backfill, most in backfill wait, and then you're going to cancel all of that in quick succession. And this is this pairing events, like canceling undoing the up maps, like 10 at a time. That's not a big event. It's the thousands of PGs that are going to appear while you do the augments. That's more of a latency event.
So thousands in one transaction, or thousands over a long time?
Over like the addition of your hardware. And maybe it's our use case that's too aggressive. Like we do host in parallel, so maybe we should just stagger them. And if that's the answer, that's fine by me, absolutely. But yeah, we typically will do a full host at a time in terms of addition to the cluster.
Yeah. Okay. Well, I'll think about that one. So I guess, yeah, and I understand clear now. You're talking specifically about the augment use case.
Yeah.
Yeah. So for the augment use case, you want to peer once, and you want to. It's like basically, let's summarize it this way. You want a way to be able to add a host or some OSDs to a cluster where in the same transaction there are up maps that do not map that map all data away from that new OSD.
Precisely, yeah.
Yeah. Okay. I'll note this into the ticket as a request. That's interesting. Yeah. Okay. I think that's a really good feedback.
Yeah, just to follow up on the configurable to increase the number of optimizations you do per balancer run. It's upmap max optimizations. I pasted it in the chat for those interested. All right, so as Dan is updating that ticket, is there anything else that people want to add to this feature request? All right, so yeah, and feel free to comment on the tracker if you want to add something, you know, after the call, and you can be a watcher on this tracker. But this will, I don't want to say for sure that it's getting planned for Tentacle, but we will have it for a future release, and we will be working on it. So you can watch the tracker for more updates there. Cool. So we've gotten through all of our topics. Is there anything else that anybody wants to add or anything we've covered today? All right. If not, we will see everybody next month, and I'll stay tuned for details about what the new topic will be, and you can follow the Ceph user dev monthly Slack channel for updates or the email threads. Thanks, everybody.
Thank you, guys.
Thanks.
Bye, all.